Ladies and gentlemen, welcome everyone. I am Dr. Roland A. Drolet, PhD in Biomedical Engineering from the University of Toronto, 1971. I am the developer and inventor of the RUMART PEM system that has helped over 1 million people all over the world who were suffering from all kinds of health problems. Today I'm with my son, François Drolet, gold medalist, Olympic gold medalist in Nagano, Japan, in short track speed skating. François, I'm very proud to present this to you. A little introduction of what I call a brief quantum theory of the analogical spring-loaded and electromagnetic universe. Of course, we could think of many universes. So I'll try to go reasonably fast because we have a number of pages to go through, but this is to be considered as an introduction to something that will be explained and discussed with the people to make sure that they understand. So we have already introduced, talk about the resonance frequency, mechanical resonance frequency of a mechanical spring model in vacuum is simply given by this. This is a mass attached to a spring which is fixed to the ceiling, let's say, and if you pull down the mass, let's say to here, and you let it go, it will oscillate, as you know. And if there is no air resistance, it would oscillate forever, really. So this is what we call the resonant frequency, which depends on the elastic constant of the spring divided by the mass that is pulling it and the mass of the spring too, okay? So the mechanical resonance frequency is this. Just pull it, it will oscillate at this frequency. Now, the Newton's law that we've seen earlier, force is mass times the acceleration, okay? Or mass times the gravitational acceleration near the Earth, g, which is 9.8 meters per second squared. So the acceleration is the second derivative of distance with respect to time. It's the change of speed, and speed is the derivative of distance. So F2 here, see F1 is what's happening there, but F2, the force in the opposite direction, is the elastic force, which will be elastic constant time x minus x0 if it's in equilibrium at distance x0 when you don't touch it. You let it know. Okay? So this is called Hooke's law of elasticity. Okay, that's what it says there. Now the resonant frequency of an electromagnetic circuit. I talk a lot about parallel plate capacitor, but you did not get the first series A of my video clips, so I'm pleased to just introduce you there. Suppose you have two plates there, metallic plate, at a distance, let's say dx between the two plates, and the radius of one plate is ρ, okay? So the resonance frequency of this circuit is simply 1 divided by 2 pi square root of 1 over L, the inductance of vacuum, multiplied by capacitance of vacuum. Remember when I talk about the complex impedance, capacitive and inductance? Yep. So these two operate in opposite ways. So there is no resistance. And that resonance frequency, it's oscillating forever. I mean, if the charges are moving there, there is a change of charge between on one or two of the plates, then you will get an electromagnetic wave which will get off, and its frequency will be will be a function of the size and given by this equation. Now, the capacitance equation of vacuum is simply the electric constant multiplied by surface of the plate divided by the distance between the two plates. And in this equation, I've realized, playing a lot with this, that when you have the surface of the plate equal to the surface of the magnetic circuit around it, supposing that the surface of the magnetic circuit going around it is the same as the surface of the plate, then you would have pi raised square as the surface of both electric and magnetic circuit, okay? Then, simply using this equation, and also the product of the distance between the plate and the length of the magnetic circuit going around it, which is simply pi squared multiplied by Ray, because taking dx as pi multiplied by Ray, and Lm the same thing, you get the exact resonance frequency that happens to be experimental. Okay? So first I didn't know how to choose these specific parameters, but I realized that they are all linked together at resonance. Mm-hmm. As the Buddhists would say, everything is linked. So this is a link also. But how is it linked? That's the simplest way. And then we get that the resonant frequency, putting the value of inductance and capacitance and inductance that we have defined there, with the specifics there, number of turns of vacuum around is 1 turn. So in the equation we get the resonance frequency, speed of light divided by 2 pi Ray, which is the wavelength. So 2 pi, so the circumference there is like the wavelength of what's going to go away, okay? But we realized in this model that Ray could be anything, could be very, very small in terms of millions and trillions of a millimeter. It will still hold up to the limit of quantum mechanics, okay? So then you have this equation giving that wavelength multiplied by resonant frequency give the speed of light. So just with these experimental things, you find the value of the speed of light, measuring E0 and the electric constant and magnetic permittivity, without having to do Michelson-Morley's experiment, measuring the time it takes for light, for instance, when you are on one side of the orbit of the Earth going towards the sun or toward the stars, and when you are going away from it. So there are experiments in history that were able to approximate the speed of light. But with this simple equation, we can get the value of it, okay? Sure. So let us go. Now you have the basis to show that the equation of the resonant frequency mechanical, see, this one is the same equation as this. And the mathematical equation are the same. So the electromagnetic vacuum can be regarded as the elasticity of the vacuum, because it's the same equation. So when you take the perfect mathematical equivalence between mechanical and the EM circuit, or their math equation, it gives us equation 1 and 3 above. It gives us that the elastic constant divided by the mass is 1 over this, but with the little calculation I've done, it gives that. It gives c squared over Ray squared, from which we get that the atomic mass equivalent of a photon would be the elastic constant multiplied by the size of the space considered divided by c squared. Okay? We know that the equivalent mass of any photon, energy-wise, from Einstein, is mc squared. And hf is the energy of any photon. So the mass, let's say the virtual mass of a photon could be the energy, hf, divided by c squared, because energy is mc squared. So we could have so when you use that, with our mechanical EM analogy, we can conclude from this equation that the mass or virtual mass of a photon divided by the mass of atomic equivalent, mechanical equivalent, gives these values. This is just combining the equation above, and also we get again that is just combining equation as it says there, okay, from 5 and 6, and here from 3, page 52, we get this, and a perfect mathematical equivalent, so that always the elastic constant of vacuum depends on rho square, rho cube, or the volume of the space considered. So the smaller the space considered, the greater the elastic constant. Okay? So in this way we can say that the whole universe can start when the quantum vacuum is stimulated so much that it gives an equivalent spring energy that it creates a Big Bang. Okay? So that's and this I've never seen this anywhere. It's just the calculation I made, assuming the quantized element volume that I just mentioned of space, and the radius of a photon to be ray, or the wavelength divided by 2 pi, then you get that what I call k rod, which is defined here 2/3 of Planck's constant by the speed of light. Okay, k rod, because this is for Rodrol, because I defined it somewhere. Okay, so anyway, where we define k rod, it's here, the elastic constant multiplied the volume of space considered. From quantum mechanical uncertainty principle, Heisenberg, we must always have close to the Big Bang initial time, tau, or the time, Planck's time, that is so-called Planck's time, which is around 10 to the minus 43 seconds. It's damn fast, okay? And for time greater or approximately equal to Planck's time, that means all the time, we must have that the maximum energy or quantum energy from quantum mechanics must be larger or approximately equal to Planck's constant divided by T Planck. This is just combining the equation for time greater than Planck's time, which is any time after this short time there. Okay, so we have the energy at this Planck's time, just with the elastic time constant multiplied by the elongation of the initial spring. The elongation square, okay, divided by 2 is the mechanical energy of the spring to break it. Then you have a Big Bang. So it's an equivalent. So then the delta x distance that you would need to do that happens to be square root of 2 times rho. You remember there's this escape velocity, square root of 2 times the speed. So in this mechanical electromagnetic analogy, it seems that if you elongate the spring, initial spring of the Big Bang equivalent by square root of 2, it breaks and you have the Big Bangs and it creates our universe. So that's something. This is using equation 7 above, when Planck's length is simply rate in our equation, the radius of the applicator, that can be anything. And this Planck's time is the speed of light times, this Planck length is the speed of light times Planck's time. So this is the energy density from particles, photon, and electromagnetic energy. So I'm going to go just very quickly on that to arrive to what I love, the rolling photons. It likes like rolling photon. So I like this expression. But here it's just expressing the energy of particle in statistical physics. It's the perfect gas law that I showed you earlier. Photon plan for details, see black body. This is the energy of photons when the temperature is so much like at the surface of the sun. Planck calculated the energy spectrum at different frequency emission at a given temperature. So we have an emission, our body emits a certain spectrum in the infrared wave. That's why with infrared camera you can see in the dark, because the temperature of the body is higher than the surrounding. Okay? Now the rolling photon summary. Equivalent mass of a photon, I mentioned it, it's the energy of the photon divided by c squared. Simply m photons c squared, okay? Equivalent radius of a photon, I've never seen anywhere, but I decided that equivalent radius of a photon would be its wavelength divided by 2p, because it's rolling, okay? And the angular momentum of a photon, any photon, which is, the angular momentum is the mass times the speed, okay, times the radius, angular momentum, mvr radius, okay? So mvr for an electron, it's n times the Planck's constant for electron. But for photons of any frequency, it's always h divided by 2 pi Planck's constant. This is simply a beautiful way to remember what a rolling photon means. Just assuming the virtual mass of a photon, we say that it's zero, the mass of a photon. But it has an energy, so it's like it would have a mass. So this is about it. For an angular momentum of a planet around the sun is the mass of the planet times the velocity, tangential velocity, perpendicular to the radius. Okay, mvr. So this is the mechanical angular momentum in what we call a square inverse field, like the electric field, gravitational field. Okay. Follow me? Okay, now we are at the beautiful end of our conversation, confirmation of Einstein general relativity. I just want to mention about 3 things that were confirmed the genius of Albert Einstein beyond any dream of the foolish guy or religious guy. This guy has never, even in February 2016, what he predicted as gravitational wave were detected. But the first verification of his general relativity theories is about the orbit of Mercury, I mentioned about. Okay, I'm not going to go long in that. Gravitational wave, March 2016, 11th February, but it was measured in September. They wanted to make very sure calculation. It's totally public, these kind of measure. They send it to all the physicists around the world. And this wave they measure, it was caused by the collision of two black holes that are about 1.3 billion years away from Earth, or 1.3 billion light years, because this is so far. And during the third way is the deviation of a starlight by the sun. And this was measured, confirmed in 1960 or 40, I don't remember the date. But during a solar eclipse, it was observed that using Einstein equation for small equation, which is here, deviation of the light rays by a large mass as the sun. Lighter mass like the Earth, you cannot measure, it's too small. Okay. But with the sun, it was measured that it was twice that predicted by classical mechanics. And so my interpretation of this little equation with this mass with a little this like that, the mass of the sun, gravitational constant, speed of light, B is the impact parameter radius of the sun in our case, because it's when light rays goes just next to the sun, so the impact parameter is this. So the conclusion there is that light is curved around the sun, according to Einstein's general theory, just as if the photon would be massive and that the sun would have twice its mass. Okay? Because the assumption that I made out of nothing, it gave sense to that. Because you say either the photons have twice the energy that they have, but that's not the case. But since it's deviated twice, if you want to understand it in terms of classical mechanics, simple, we could say that it behaves as if the mass of the sun would be twice what it is. A reason? Quantum mechanics genius, Albert Einstein. That's it. And the best Einstein general relativity equation for electromagnetism, this is what I talk in page 12. It shows also that when you include not only mass in the universe, but you include electromagnetic energy, like in the quantum vacuum, then the equation are changed as if there would be as much electromagnetic energy as mechanical energy of matter. That's fantastic. But this is what was explained in page 12. And for today, that's the end of our sunlight. And François, thank you very much.
Thank
you are such a great listener.
Very interesting.
And if you didn't understand a lot of what I was talking about, I would not be talking to you about this. But I know that this is going to work in your mind, like when you were 5, 6, or 10 years of age. You were sitting on the couch sometime, and your mom asked, "What the hell are you doing?" You look at your mother and you said, "Mom, I'm thinking." So I wish you'll be keeping thinking for a long time. So that's the end of this clip. Thank you for your attention. I hope you enjoyed it. And please keep smiling till the next clip.